welcome to Objects Falling with Lincoln Science. So let's take a look at when gravity acts on two objects and they're falling on Earth. So we're talking about Earth, so I'll use the acceleration due to gravity be 9.81. We'll talk about why that's the same for every object. Due to gravity means it's due to a force of gravity. And I just want to start out by saying that gravity, if we just say gravity on Earth, that's not saying enough. I need to say force due to gravity because force due to gravity is going to be different for different masses. But if I say acceleration due to gravity, then that's going to be the same for different objects. Let's talk about why that's true. Let's look at two objects. We're talking about right here, we're going to talk about a golf ball. So it's got a big mass compared to a little tiny ping pong ball, but they have about the same surface area. And when I first let go of them, there's no air resistance force. So the only force acting on it, F net here, is going to be small for the ping pong ball because it has less mass. And the gravity, it's heavier. If you hold both balls in your hand, you can tell that the golf ball is heavier. So the force due to gravity on it is bigger. But it has a bigger mass. And when you go to divide the big force net divided by the big mass, you end up getting acceleration of 9.81 meters per second squared. Instead, with a little ping pong ball, you got a little tiny force. And that little force, well, due to gravity, it's lighter, but it's got a teeny little mass also. And when you divide those numbers, you end up getting acceleration being 9.81 meters per second squared again. So if you've got no air resistance, either because, right, you're in a vacuum or maybe you're on the moon or something, but if you have no air resistance, your acceleration due to gravity is going to be the same, even though your forces due to gravity are very different. And that's because the masses are different also. This is also true at the very start, when we first let go of the balls. Since they're not moving, there's no air resistance. Now, once they start moving, they're both going to be speeding up about the same, because remember, they have the same accelerations. So after a very short period of time, the resistance due to air resistance here, the force due to air resistance on one, is essentially the same as the force due to air resistance on the other, because they're both moving about the same since they both had almost no velocity at the start. But they had some velocity, they started getting some forces, and let's take a look at how those forces affect the overall movement, which means we need to know the net force. So I've made that in red here. So the net force on the ping pong ball is going to be tiny, because this air resistance force basically cancels most of the gravity force. There's hardly any net force anymore. This goes very small, which means acceleration is going to drop off dramatically. Instead of being 9.8 meters per second squared, maybe now it's just down to 2 or even 1 meter per second squared. Instead, the golf ball here with its bigger mass and its big gravity force downward, its air resistance is hardly affecting it at all. It's a very small percentage of that. So that my F net's hardly changed. So that even though I'm dividing by a bigger mass, I still get an acceleration that's maybe 8 meters per second squared or 7 meters per second squared. It's still pretty big. And so the golf ball is gonna speed up more and more compared to the ping pong ball because its F net is still pretty significant. And if we wait a little while and we're just looking at the forces, the two balls aren't going to be next to each other at this point because this golf ball is going faster and it's going to be winning. But its air resistance force is bigger because it's winning. Because it's moving faster, its air resistance force is bigger. That's this green one here. But when you go to cancel the gravity force in blue, the net force here in red is still pretty big. And so the acceleration on the golf ball is probably something, I don't know, like 5 meters per second squared or 4 meters per second squared, but still accelerating a lot. And instead, this guy, the ping pong ball, is down to no acceleration because it's moving fast enough now that the upward force due to air resistance is canceling the downward force due to gravity. And the ping pong ball is gotten to A equals 0 here. So it's still moving downwards, still could be going pretty fast, but it's not accelerating. It's not speeding up anymore. It's reached terminal speed on its way downward, as opposed to the golf ball, which is still speeding up, moving downward faster and faster at every second. If it gets fast enough, eventually this green vector upward will cancel the blue vector downward, but it's got to be going a lot faster before that's going to happen, before it reaches its terminal speed. So that's why with air resistance, this denser object, this golf ball, is going to win over the ping pong ball. So hope that helps you answer those questions. I could ask questions about being on the moon where there's no air resistance, or I could ask questions about here on Earth, looking at these comparative objects. Good luck. Sorry I couldn't be there for the review.